All right. Yeah. Let's get started. Okay. Good morning, everyone. Yeah, my name is Ki-Jin Song, and I'm a postdoc researcher in the School of Architecture at UT Austin. Welcome to our lightning talk series on smart city research. This talk series is funded through the UT's Good System project. So we invite speakers from academia, industry, and the communities to share the research events and the needs related to the smart cities. So if you are interested in this topic, please feel free to visit our website for our past talk and the activities at smartcity.tech.utexas.edu. Excuse me. So today we are very excited to have Mr. Nathan Shay as our guest speaker. Nathan is a solution engineer at StreetLight. He has built expertise in transportation planning and traffic engineering in both private and public sectors before joining the StreetLight. Data-driven decision-making has always been at the core of Nathan's work, which has always included the travel demand modeling, data-driven safety study, corridor studies, and congestion analysis. Now, Nathan gets to spread his passion for data by helping transportation planners and engineers integrate StreetLight's metrics into their processes to make the transportation industry more efficient, equitable, and data-driven. So today, he will talk about the transportation analysis using the big data. So without further ado, yeah, I'll pass the mic to Nathan.
Thanks, Kijin, for that intro. As Kijin said, I'm a solutions engineer with StreetLight, and I'm here just to talk a little bit about how we use big data to help make better transportation decisions. I'm actually not too far away, just down the road here in Houston, working out of my home office today. So it's nice to be here. Thank you for having me. It'll just be a quick agenda today. The first, we'll talk a little bit about what StreetLight is, and then we'll talk about how people use it, and then I'll quickly pull up the platform and show you a couple examples from Texas that we can ask some questions about, look at some of the details, what it looks like in our platform. So as I'm sure all of you know, if you're interested in smart cities, the world around us is changing quite rapidly. We've got a big push for EV adoption, ride hailing that at levels that was unthinkable 20 years ago. The pandemic has increased e-commerce, historic investments in infrastructure, and obviously the pandemic also impacted how a lot of us work. So that just increases the need for us to have data to understand what's going on our community roadways. But luckily for us, everything out there that's moving these days is transmitting data. As those of you who are interested in smart cities likely know, we're taking in a lot of that data from connected vehicles, the Internet of Things, as well as a lot of contextual data about the locations and ground truth data in the form of permanent counters to process trillions of data points into actionable transportation, multimodal transportation metrics. So basically the power of what we do is taking all of that data, and in a few clicks, transportation planners and engineers can get metrics that they're familiar with for any mode nearly anywhere. And we'll see a lot more of this a little bit later, but here's a few examples of some of the metrics we do, like origin destination, volumes for vehicles, bicycles, pedestrians, as well as routing information. Just to name a few, to understand the top routes between something like downtown and the suburbs. So there's trillions of data points, like I mentioned, and an audience that probably skews a little more academic like yours, I'm sure would love to get your hands dirty with that underlying data and kind of try to pull the insights out of it. But unfortunately, a lot of those in industry, working for public agencies, working for consulting firms, doing work for public agencies, they don't have the time to kind of learn about servers and data science and machine learning. So what we help them do basically is turn that big pile of data into something that they can relate to and make decisions based off of. So that leads us into kind of part two of how people actually use all of that data. Like I said, it allows us to deliver transportation metrics on any road, any mode. And that the big power of big data is it's scalable and pretty ubiquitous. So we cover all of North America, and you can do something like analyze AADT at the state level, look down at a neighborhood and look at what the speed on all the roads are in that neighborhood if you're doing traffic calming work, or even get down to an individual intersection and start looking at what the turning movement counts look like, or what pedestrian activity looks like at that intersection. Here's just another slide indicating some of those metrics that we use. Again, we try to make that big data into something that's really relatable to those in the industry, like volume, origin, destination, routing information. And we're able to do that for multiple modes. So that includes pedestrians, bicycles, passenger vehicles, commercial vehicles, bus and rail. And just recently, we're actually unleashing through some custom projects the power of connected vehicles, that we can actually look specifically at electric vehicles and how those vehicles move through our communities. So two, what do people do with all those metrics? So you've got all these metrics. What are they able to do with them? Like I said, our goal is to help solve people's problems and help them make quicker decisions. So I apologize. I know if a Texas audience, bringing a California example might not always be the most popular thing, but this is a really great example of how effective use of data can really help solve a problem. So Samtrans here in kind of the suburban or metro region of San Francisco runs a lot of commuter transit kind of to San Francisco. And kind of in that post-pandemic, coming out of the pandemic era, they had a lot of kind of decrease in ridership, which was common across many transit agencies. And they were trying to figure out what to do to solve that problem. And rather than doing a very costly, very long household travel survey, as one might have traditionally done in the past, they were able to use our metrics to get origin destination analysis between the city and the suburb at 15-minute granularity. And they were able to look at how things had changed kind of in that pre-pandemic and that post-pandemic period. And what they found was that people were spending less time at the office downtown. Those kind of peak periods has shifted. So whereas before it had been kind of more stereotypical, maybe 6 or 7 a.m. to 5 or 6 p.m., post-pandemic, it was more in a 9 a.m. to 4 p.m. Peaking activity. So they actually implemented changes in their transit schedules based off of this new peaking that they identified with StreetLight. And within 2 weeks of the change, their ridership had increased by 30%. So that just shows kind of the power of being able to do something like this very quickly, harness the power of all this data that's just sitting out there, and make some decisions on it. So the third piece of what we do is we work well with other data sources too. I'm sure as smart cities interested folks, you've seen lots of different types of data coming from all over the place. So a lot of departments of transportation will do kind of traditional traffic counts. We're not trying to replace those, especially those high quality permanent counters are super valuable for us to help train the models that result in our volume estimates. But what we're able to do is kind of fill in those gaps. So you can only put so many counters out in the field. You only have so much staff. You only have so much equipment. We can help fill in all those other areas. Another example is you might have really high quality crash data. Before working at StreetLight, I was a consultant in Texas, and I know that TxDOT has a really great crash database. But something that's super useful if you're doing a systemic crash analysis is understanding speeds and volumes on all the roads you're looking at. So we can bring that additional context to other types of analyses, and we can do it at scale and relatively quickly. So that is my quick just pitch on what StreetLight is and how people use it. Were there any quick questions on that before I flip over to the platform and show a couple examples? All right. If not, I'll flip over to the platform. And those of you who this might be your first time seeing the StreetLight platform, this is the visualization component of our platform, where you can look at the outputs of an analysis you set up. There's another part of the platform, and we have plenty of training to show you how to kind of go in and you draw your lines and set your data periods and all that. You wait a few minutes or a few hours, depending on the size of the analysis, and you can visualize the metrics here. You can also download to kind of do your offline analysis or export ArcGIS Online or many other ways of integrating into kind of standard workflows. But what we're looking at here is the visualization platform, and kind of just framing the screen. We've got kind of a title and just some information about the analysis we've run at the top of the screen. On the left are just some filters that we can use to kind of adjust what we're looking at based on the parameters we set up when we initialize the analysis. And then on the right, we can dig a little deeper into the details as we kind of look through our analysis. So this first kind of pair of analyses that I'll show is just a very large scale corridor. This is Interstate 20 in the Permian Basin in Texas. Some of you may be familiar. Permian Basin is pretty rural, but it's characterized by a lot of natural gas industry activity. So it's pretty rural. We've got the small kind of metro areas of Odessa and Midland, but this is like a 200-mile corridor of Interstate 20. And what I've done here is I'm just looking at kind of the volume for all vehicles going through the corridor. And if we flip up into 3D, you can see sort of unsurprisingly, you've got a little more traffic around the cities, lower traffic in the more rural parts. But what gets interesting is when you look at the same corridor, but you look specifically at truck activity. So in some of these more rural parts of the corridor, you can find truck penetration rates of over 50% of the total traffic being trucks, and the majority of those being big, heavy trucks. So that's very important when trying to understand what a corridor needs, what the pavement needs to look like, what the network needs to look like, what goods and services are moving on your roadways. And similarly, in this type of analysis, we can look at not only the volumes, but we can look at the speeds. So we can look at what some of the truck speeds are. It's a rural area. There's not a ton of congestion. It's roughly in the high 60s, low 70s. And we can go back and do the same thing for our vehicular traffic, which includes all of those kind of passenger vehicles as well. Oh, not travel time, speed. And see that the personal vehicles are bringing that average up to 76, mid-70s miles per hour. So that's also important to understand when you've got such a high penetration rate of trucks, when you've got kind of two different traffic streams maybe moving at two different speeds. That's really important for understanding kind of safety implications as well as mobility implications of that. So that's just a real big kind of rural mixed corridor example. In a more urban context, closer to home for me, this is an example of our multimodal metrics. This is specifically looking at pedestrian activity. And here I've kind of blanketed the Houston inner loop area with a hexagonal grid it's an industry standard called H3. For those of you who are really nerdy about it. But what we're looking at is hotspots of where pedestrians start or end trips. So again, we can kind of flip up into 3D and get a better view of where those hotspots show up. So if you aren't familiar with Houston, let me turn on the street map to get a little more context. This is downtown Houston. So you've got a kind of spike of activity there. Over here is the Galleria, which is a large mall. So you've got a lot of people walking around the mall. And then down here, kind of south of downtown, this is the Texas Medical Center, which is one of the largest, or is the largest medical center actually in the world. So a lot of people walking around from hospital to hospital, from hospital to lunch, and otherwise in this area. Also in this area is Rice University and a very large urban park called Herman Miller Park. You can also see smaller flips and pedestrian activity around the University of Houston. As I said, over here on the right, you can dig a little bit more into the details of what's going on. You can look at things like how long the trips people are walking, how long they're taking, what the distance is. Unsurprisingly, with pedestrian trips, you've got many shorter trips than kind of the higher areas. You can look at speed. Also, I always like to look at for pedestrian planning the security, which is just the ratio of the kind of crow's fly distance to the actual kind of path travel. And when you get up into these high levels of security here, 6+ or even 5 to 6, that's indicative of a very circuitous trip, and that could be indicative of multiple things. So if you're analyzing a park, maybe that's a bunch of people just walking around, getting some exercise. But if you're analyzing a more utilitarian area where people are likely walking for commuting, to go get lunch or whatever else, if that security is high, that might indicate that there are some barriers for pedestrians in the built environment that might need to be overcome to actually complete those trips. So that's important for our planners who are focused on accommodating those multimodal options. So diving a little deeper into the Texas Medical Center, I've just drawn a kind of custom polygon that encompasses most of the hospitals in that large medical center I referenced. We can look at, I'll switch this back just so it's a little less distracting. We can look at how far people are coming. Actually, let me flip. There we go. So this will show you how far out people are going to and from the medical center from. So you can see we've got folks coming all the way out from Austin and Round Rock, all the way out to kind of Lake Charles and into Louisiana, almost all the way up to Dallas. You've got significant enough folks to look at when we're looking at an average. This is just an average over all of 2021. So you can really see the regional reach of the hospital this way, and how this medical center is really serving not just Houston, but wider kind of Texas, Louisiana region. Sort of looking at the other side of that picture, again, it's the medical center. This is what we call our top routes analysis. I'll switch it to the other mode again, make it a little more clear what we're looking at. And this is kind of translating that origin destination impact into the actual impact on the roadway network. So these are showing all the roads that people are using to get to and from the medical center. So as you can see, unsurprisingly in Texas, a lot of that, or the majority of that volume is coming in on these interstates and highways kind of emanating out throughout the region. Again, we can kind of flip back and forth, look at, open this too early in preparation for this call. It wants me to reload. We can look at the trip attributes and just get some more, and I'll turn this to percentage and pie chart and look at, again, things like trip length distribution. So you've got a lot of folks coming from pretty locally, but you've got kind of a long tail here with the 20 to 30, 30 to 40, and then still a good chunk of people in that over 40 miles away coming to the hospitals there. Similar security ratio and traffic speed, travel time, but obviously vastly different than the pedestrian analysis we were looking at. You've got much longer trips, much faster speeds, much less security generally. So that was just a quick kind of whirlwind tour of some of the types of analysis we could do. So does anyone have any questions on this or anything else that I've talked about so far?
I have a question.
Sure.
First of all, thank you. This is super interesting as we're going here. I'm really enjoying it. I'm curious, you were talking earlier kind of about like ride hailing and how that's such a big thing. And I'm also curious for like micromodal, like I'm thinking Lime scooters, things like that. Does this platform have any information on either of those?
Yeah, so as far as micromobility goes, we don't take in specific like carrier data, so we don't take in data directly from the Limes or the Spins of the world. However, since we do pedestrian and bicycle analysis, a lot of those rental bikes and whatnot will be reflected there, and you can do some interesting kind of before and after, like where biking increased after the institution of one of these programs, things like that. As far as TNCs or Ubers and Lyfts of the world, again, we don't have a separate mode that you can analyze looking at that, but that's something, especially when you're getting into areas where there's very high penetration of TNCs, like airports, that by looking at things like that circuity ratio, you can start looking at the impacts that those are having on congestion and traffic in the area. So what we've found in a lot of our research is when you look at these very circuitous trips in these areas, like hotspots of bars and clubs, as well as the airports of the world, the TNC vehicles are, as you probably know, driving around in a lot of circles, so that circuity ratio really goes up on there. So when you focus in on those trips that are making those very circuitous trips, you can get an understanding of the impacts that those TNC companies are having on our communities.
Nathan, I also have a question. For me, it was really interesting that you used the traditional traffic count data and actually fill in the gap in your map using the data. So in one of our ongoing projects, it might not be a little different, but we also use the limited number of points of the air quality sensors to develop some high resolution air quality map and try to fill in the gap even in where we don't have the air quality sensors. So regarding the data sources and the methodology, could you a little bit explain more about that? And other than the DOT's traffic data, are there any other data sources you used in your analysis, and also what type of machine learning algorithms you used in your analysis?
Sure. So we take in all kinds of data. So this data include, obviously the biggest is the connected vehicle and location-based services from smartphones that actually show us the movement. But we're taking in those permanent counter stations as that ground truth that kind of trains our models. But some of the other contextual data we take in is things like roadway classification from OpenStreetMap network. We look at things like weather patterns, land use, all points of interest, all these different things, and kind of developing our machine learning algorithms that create estimates of volume for all these different modes. As far as the actual machine learning we use, I'm not the expert on this, but it is, we have white papers that describe it, and it's a extreme gradient boosting algorithm. Is about as much as I know about it. I'm not the one backstage writing the code, but that's essentially how that's the type of algorithm that they use to take in all this data and produce our volume estimates. Did that answer your question?
Yeah. Thank you so much. Yeah.
Yeah, no problem. And that just also spurred another thought I had about that. It's interesting you're talking about that air quality project. We've actually been talking to some public agencies who are doing something similar, where they're taking in this really granular data at like this handful of locations, and they're looking at how they can actually use metrics like ours to help understand, okay, this is the traffic condition at this location that has this air quality kind of profile. Can we look at other roadways in our network, compare those roadway profiles in terms of speed, vehicle mix, all of those things from StreetLight, and kind of, like you said, fill in those gaps. We can't have those super granular data collection sites everywhere, but if we understand what is kind of driving that air quality, we might be able to estimate using things like traffic metrics from StreetLight.
Interesting. Any other questions? No. Yeah.
I saw activity in the chat, but Brent was sharing the white paper I referenced. So that's a little bit more about the methodology. And we'll give you a little bit more detail on those algorithms that I was talking about.
Thank you. Yeah. All right. So yeah, I think, there's no questions anymore. So maybe it's a time to wrap up. All right. So thank you so much, Nathan, for your wonderful talk today. And we'll post your videos on our website soon. If you are interested in our future talk, you are really welcome to visit our website at smartcity.tech.utexas.edu to see our past talks and any information for the future talks. So our next presentation will be held on next week, March 17th, with Brad Bargains from Verizon. So he will talk about 5G, the future of public sector technology. So I know next week is the middle of the spring break, but it will be really fascinating talk, especially for those who are interested in how private sectors work for the public sector technology. So thank you everyone for joining the talk, and I hope you have a wonderful weekend and spring break. Thank you.
Thanks for having me and joining before spring break, everyone.
Thank you, Nathan.
Yep. Thanks.